Welcome to today's lesson on percentage change, which is the first of several on this topic because percentages turns up in so many questions in GCSE. It is one of the most important building blocks you have to master. And so there'll be about 5 little videos on this because it can turn up in lots of different ways. And today we're going to look at percentage change and introduce this idea of the percentage after the change, the PAC. And what we're going to look at today is how we find the PAC and how we're going to use it. Right. With PAC, we always start with 100%. So whenever we're doing percentage change, you must remember we start with 100%. So for percentage increase, the way we calculate PAC is just 100% plus the percentage change. For a decrease, it's 100% minus the percentage change, which means for percentage decrease, really what we're working with is the percentage that's left after the change. We're not so much interested in how much has gone down. What we're interested in is what's left. Well, an example, right? We want to increase an amount by 10%. What's our percentage change going to be? We always start with 100%. Plus 10% is 110%. But if you put 110% in your calculator, you'll get out 1.1. And we can work with either of those versions because they're absolutely identical. 110% is the same as 1.1. Similarly, to decrease an amount by 90%, what will be the PAC? Remember, we start with 100%, take away 90, that's going to give us 10%, which we put in our calculator, we'll get 0.1. So our PAC is 10% or 0.1. Right, here's a few for you to have a go at. So what I want you to do is get your pen and paper out and then just pause the video, just answer these, and then in 2 seconds, unpause the video and you'll see the answers. 2 of them are increases and 2 of them are decreases. Right, here's the answers. So 90%, we're going to go have a PAC of 190%. 32%, we're going to have a PAC of 132%. Decrease of 70, 30%. Decrease of 27%. 73% is going to be left. Now, on my maths, which is an exercise we're going to do quite a lot of, it comes up with this idea of the multiplier rather than the PAC. It's exactly the same thing. So to increase an amount by 44%, what we do is we're going to multiply it by 144%, but as a decimal, that's 1.44. So for a decrease of 40%, we've got 60% left. So we're going to multiply by 0.6. So having made note of that, can we just put in the decimal versions of the PAC for these? One for an increase of 23% and one a decrease. So again, pause the video, get your pen and paper out, just write down your answer, then unpause the video and check you got it right. Okay, so 100 added on to 23 gives us 123%, but as a decimal, that's 1.23. If we take 42% off 100, we're left with 58%, but as a decimal, that is 0.58. So we'll quickly look now, introduce how we're going to use this PAC, and we're going to use 2 ideas. The value we start with, the original value or the old value, turns into a new value or the NV. And so in our function machine, we have the OV, and all we do is multiply it by the PAC, and that will give us a new value. But equally, there's questions such as the sale question where we say something's gone down by 20%. In the sale, it now costs blah, blah, blah. What does it cost before the reduction? And then we have to find the old value. And then what we do is we find our PAC and we do new value divided by PAC. So what we're beginning to see is that percentage change is basically either a multiply or a divide. And the two equations we must know are new value is the old value times the PAC, or the old value is the new value divided by the PAC. So please pause the video and write that down. This is what we have to remember. And what we'll then do in the next few videos is show you how we're going to use these equations in anger. So thank you for listening today, and I hope you'll tune in for the rest of the videos as soon as you can. Thank you.